Good day. My name is Raji Babatunde Kasali. I'll be your instructor in this course of basic technology. Our topic for today is drawing practice. And in our drawing practice, we are going to examine the playing figures. Now, as a learner, what do you stand to gain at the end of this course? First, you should be able to identify regular playing figures. You should be able to construct a regular playing figure of equal area. You should be able to find the area of regular playing figures, and you should be able to enlarge and reduce playing figure. Now, the topic improper. You go to viewing center, you go to stadium to watch football. During the commentaries, and even sometimes after the football analysis, you hear that the size of the Barcelona pitch is very large. Santiago Bernabeu in Real Madrid is as large as is as so lengthy as this measurement. Now, how do they come about that? This is through the use of the application of formulas, which we are going to learn in our area of regular playing figure. If you look at the shape of your football pitch, it has a rectangular shape. So we are going to learn how they come across the measurement of this playing figure or this rectangular shape on our football pitch. Now, there are other places, locations that have other shapes, but for this, I'm making an example of football pitch, which has a rectangular shape. Now, area of playing figures refers to the amount of space enclosed within the boundary of playing figure, that is the space occupied by that figure. Now, your football pitch has a lining, it has a measurement, which is being used to demarcate the main football pitch from the outside line, or say the throw-ins. Now, when the football player wants to throw, it stands on the line. And that line forms the demarcation or the boundary on that football pitch. The screen we have here with us. Now, if you look at it, there's a boundary around the edges. Now, we can measure the area of this television set we are watching in front of us through the application of some formulas in which we are going to examine in the future. So the area occupied by this screen that we have with us can be referred to as the area of the television set we have in our phone. So if you look at it, this TV screen has a rectangular shape. So the boundaries that this TV screen occupies is known as the area of the playing figure. So it can also be referred to the number of square units the playing figure contains. It is the inside shape or shape measured in square units. So in the subsequent slide, we are going to see, we are going to examine it diagrammatically. Now, look at this diagram we have here. This is a rectangular shape. For us to calculate the area, we have to examine the boundary. Now, this is what we describe as the boundary. This line, this surrounding line, is all described as the boundary. So for us to calculate the area of this plane figure, for us to know the area of the plane figure, we are going to examine the area. Now, look at this. If you look at the image here, we have several units. These several units makes up the complete area. So for us to get the total area of this plane figure, if you look at it, this looks like your football pitch. Now we have to calculate the total number of the square units that we have here, both on the length and the breadth. So here we have 1, 2, 3. So we have 3 square units here. Then on this side, we have 1, 2, 3, 4. So we have 4 here, then we have 3 here. So there, from what we have on the screen, the area of the above figure is 12 square units. If you count 1, 2, 3, 1, 2, 3, 4. And when you multiply 4 by 3, it's going to give us 12 square units. So instead of using the above method to determine your area of plane figure, we are going to multiply both sides of the plane figure, giving us the result or giving us the area of the plane figure. So the product of the two lengths of the side is measured in a unit called centimeter square or meter square. So that's why when you see the measurement of football pitch or any sporting center being told that they are being graduated in the units as far which include centimeter square or meter square. So when I say they are being graduated, that is the unit of measurement of your plane of the length of a rectangular shape is centimeter square or meter square. So you have to include the units of graduation or the unit of measurement in your area gotten, or the product of the area you got for your plane figure. Now, the first plane figure we are going to examine here is the square. A square has 4 equal sides and all its angles are right angle. A right angle is a 90-degree angle. When you place your protractor here, it measures 90 degrees. So all the 4 sides are equal and they form a right angle triangle. Now, if I cover this part of the square and this below part, you see that it forms a right angle from this side, right angle from this side, which is 90 degrees. On this side forms 90 degrees. On this side, so all the edges forms 90 degrees. So all the equal side, the 4 sides are equal and they form right angle, which is 90 degrees. So how do we determine the area of our square? We determine the area of our square using this formula. So we are not going to use the method of counting the square units that we applied in the previous example. The shortcut is to multiply the side by side. So this is a side, this is another side. So if you are to get the area of a square, you have to multiply the unit of this side or the measurement of this side by this side to give us the area of our square. Moving forward, rectangle. Its opposite sides are equal. Now, we are the opposite side. This is opposite to this. This is opposite to this. So the opposite side are always equal. And its angles are right angles. Now, like we said in our previous example where we examined square, if you look at this, measure it, take your protractors to measure it, on all the angles, on all the edges, you are going to see that it's going to form 90 degrees. So all its angles are right angles, and right angle is what? 90 degrees. So how do we get the area of a rectangle? It is being gotten by multiplying length by breadth. So that's how you can calculate the area of your rectangle. So when next you go to National Stadium in Sule, take the measurement of the length and the breadth to get the area of the pitch. Now, rhombus. A rhombus has all its sides equal. These are the sides. All the sides are equal. Now, how do we determine the area of our rhombus? We can determine the area of our rhombus by multiplying the base by the height. Moving forward, a parallelogram. It has its opposite sides equal. From the previous example we have examined, by now you should be able to understand one by opposite. This is opposite to this. This is opposite to this. So I said it has its opposite sides equal. This is equal to this. This means this is equal to this. This also means this one is equal to this. So its opposite sides are equal. Its angles are ordered down right angle. So they do not form right angle. And mind you, I said right angle at 90 degrees. So this is not 90 degrees. The angles are not what? 90 degree angle. So you can get the area of a parallelogram by multiplying the base by the height. Now, we move to the next slide. Trapezium. A trapezium has 2 opposite sides parallel. The opposite sides are parallel to each other. And we can get the area of a trapezium by multiplying half by area plus breadth. You add the area plus breadth, multiply it by half, then you multiply everything by half. So 1/2 means half. Now, circle. Circle is another plane figure. It has 2 opposite sides parallel to each other. You can get the area of your circle by multiplying pi times radius times radius. So this pi is, you can represent it as 22/7 multiplied by r square. So radius times radius form r square. So this r square simply means radius times radius. And this pi can be represented mathematically or numerically as 22/7. Triangle. You can get the area of a triangle by multiplying half times base times height. So these are the edges of your triangle. Now, let's construct a plane figure. Here we are going to construct triangle given the 3 sides. Now, The process of constructing a triangle is very easy. Now, the first thing is to draw line AB. Now, this lesson is accompanied with images to explain to us so we understand in details what we are talking about. Now, this is point line AB. So the first thing to do is to draw your line AB. Now, with center at A. Now, get your compass. Get your compass with the given radius. After measuring the radius, now let's assume the radius is 10 centimeter or 5 centimeter. So you place your radius at your compass attached with pencil on the ruler, measure 10 centimeter like this and place it here. So wherever it gets to, draw an arc. When you draw an arc from point A, when they say with center A, that is, you are going to place your compass on this point A, then you draw this arc. So this line that we have here is what we describe as arc. Now, with center B and radius BC, with center B, now, depending on the radius being given to you, but here, the radius given to us is radius of BC. Now, you bisect another arc here. So this is what I mean by arc. You bisect it. After bisecting the arc, another arc that cuts at the previous arc. So it will intersect with the arc coming from point A. When you make point A your center, you draw this arc here, then you draw another arc from point B. Now, you are to draw a line. Now, connect from point A to the arc you draw, where intersection occur. Now, when you draw your arc here, intersection occur. What I mean by intersection is the two arcs meet each other. Then you connect a line from point A to the intersection, then another line from point B to the intersection. Then you make the point of intersection point C. So we have been able to construct a triangle. So from the scale, we can also see that I have connect point C to A and B. So connect C to B, then C to A. So that makes our triangle. Moving forward, how do we enlarge and reduce plane figure? Now, an object is enlarged when all of its dimensions are changed in same ratio. Thus, the enlargement is also called transformation. So there may be needs, let's say for example, enlargement and reduction are important when you want to design a building plan. Tales has it that back in the days, when architects want to design a building plan, they have to get paper that's as large as the land where the construction is to take place. But with advancements in technology, we have been able to devise method of reduction and enlargement. So with that process, you can have a plan of your building as big as Sambisa Forest on just A4 paper using enlargement and reduction. So enlargement alternatively can be called transformation. So each of the length of the object is multiplied by the same number called scale factor to obtain the enlargement. When the scale factor is less than 1, the original object is reduced. So let's see how we can reduce the side of a given rectangle by ratio 4:7. So we are going to go to the next slide and return so as to follow the instruction we have here on the screen. So it says, draw the given rectangle. Now, this is a rectangle being given to us. Point A, point B, point C, point A, point B, point C, and point D. Now, the next thing says, choose point P at any convenient point distance from the rectangle. Now, we picked our point P here at any convenient location. So, we pick our point P on this angle, radiate line from P passing through all the points A, B, C, D. Now, this is our point A, point B, point C, and point D. Now, from point P, which we have here, you are going to radiate a line, that is, pass a line across all the points. So, from point P, we have this line passing through here. Point B, this is it, coming from point P. All your radiation has to come from point P, their roots or their origin is point P. So this radiates to this radiates this radiates point C, and this radiates point D. Now, what do we do next? Divide a PA into 7 equal parts. Now, remember, our rectangle has 4 points, so we are dividing into what? We are going to have 7 lines to be able to have the reduction. Now, divide a PA into 7 equal parts. Now, this is PA. Now, the easiest method, or the easiest way for you to do is just step on this PA 7 times and make sure the steppings are equal. That is, you can, if you like, you can make the line thin or you can make them visible. Just draw a point A. Now, what we mean by this 4 and 7 is that there's a measurement that's taking place up to this place, which makes it 4. Then from here we have 5, 6, then we have 7. So the steppings is what got us to this 0.4, 0.7. Remember, from here it said divide a PA into 7 equal parts. This is our point P, this is our point A. Then you divide it into 7 equal parts. So when you divide it into 7, you can, if you like, you can mark it 1, 2, 3, 4, 5, 6, 7. So after dividing it into 7 equal parts, draw a line A1, the A1, D1 from the unit 4, 1 parallel to AD. This is your A1. Let's take it again. It says, draw a line A1, D1 from unit 4. Where is our unit 4? Unit 4 of our division of the line. Remember, from here it says, divide a PA into 7 equal parts. This is the PA. Now, from that PA, you are going to get to the point 4. So, draw a line A1, D1 from unit 4, 1 parallel to AD. So, you draw a line from point 4. This is it. So, this makes it D1. Extend this line from point A1 to D. On your point 4, make the point A1, then extend the line upward. That line becomes D1. Draw D1, C1 parallel to DC. D1 and what? C1 parallel to what? DC. So that is what we have here. Draw C1, B1 parallel to CB. D1, then C1. So this, your line is going to be very thick here because you are joining several lines together. They are passing through the same point. Then draw B1, A1, B1, A1, parallel to BA. So you have to make sure that all your new line are going to be parallel to the original line from where they are coming from. So B1 to this, B1 to B, A1 to A1. So you draw A1, B1, A1 parallel to BA to obtain the reduced figure A1, B1, C1, and what? D1. So with this, we have been able to reduce this image. It's bigger than this. The image, if you see the image that is formed behind, this is bigger or larger in size, but it has been reduced at this on this other rectangle formed behind. So this needs a lot of practice. You cannot get it done at once. You need to practice a lot. Now, how do we enlarge and reduce using a radial method? So the first thing you need to do is to draw the given rectangle from the image. You need to work with the image. Now, in any question being given to you, it will be accompanied with images to help you achieve your task. Now, draw the given rectangle. Choose point P, very similar to the one we did earlier. Choose point P at any convenient distance from the rectangle. So we chose that point P. It is very, very similar to what we did earlier. So radiate the line from point. In fact, this as well is a radial method. We used a radial method. So if you understand this first slide, this first enlargement and reduction we did here, you should be able to pick this second one. So radius line from point P passing through all the points, just as we did in the first one. This line passes through this passes through this, point A, the line from point P passes through point A, it passes through point B, it passes through point C with their origin, point P. This is their origin, this is their root where they comes from, then point D passes through it. Then divide PA into 6 equal parts. Like I said earlier, you can step on it 6 times. Make sure they are equal. So these are step 4, step 6. So step 5 should be in between here. Draw a line A1, D1 from unit 6. This is unit 6, A1. Label it A1. Do not forget, like I said, your questions will be supported with images at all times so that you can have something to reference to. Now, after drawing a line A1, D1, parallel to AD. Now, most of all your points will be parallel to the roots where they are coming from. So A1, if you look at it, A1 here, D1 is parallel to this point A, and D1 is parallel to us, this D. And if you look at it, C is parallel to C, B is parallel to B. So you have to be careful, study your diagram very, very well before you attempt these questions or any question given to you. Next is to draw D1, C1 parallel to DC. I already said it. D1 parallel to what? DC. So D is parallel to D1. C is parallel to C1. Draw C1, B1 parallel to CB. We've done that. C1 is parallel to this. And B. Remember, don't lose the sight of our original drawing. This is our original drawing. This is it. Now, this is the point A. It's radius to this, point B, point C, point D. So if you can have your eye, read this diagram, read your drawing very, very well. Examine it. This is our original drawing given to us. So if you can get this, you'll be able to get the B1 or the enlargement that we are doing. So draw C1, B1 parallel to CB, C1, C1, B1. So you can see them, they are parallel to each other. Draw B1, A1 parallel to us, BA. B1 towards A1, this is our A1. So you can see them parallel towards each other. Then draw B1, A1 parallel to B1 to obtain the enlarged figure A1, B1, C1, and what? D1. Thank you very much. Now, here is your evaluation. Name at least 3 regular plane figures. Construct regular plane figure of equal area. Find the area of regular plane figures. Enlarge and reduce plane figure. Now, you can get questions to enlarge and reduce plane figure from your textbook. And as well, you should be able to get questions from your textbook where you can find examples on tests or classwork on finding area of regular plane figure. So with the formulas that I've given you above, you should be able to attempt questions arising from that. Thank you for watching. My name is Raji